Assalamualaikum and good evening to everyone, and especially to our beloved lecturer, Madam Hanani Mutiazik. We are from Group 9. We present about the effect of garlic essential oil on sunflower oil oxidative stability during a accelerated storage study by FTIR spectroscopy. And this is our group consists of three group members, which is Husaini, Nur Farahi, and Nur Azlina. My name is Muhammad Hussein Ahmad Jafar, and I will talk about the introduction and the discussion. In recent years, there has been growing global demand for healthier food options, particularly in the context of reducing lipid oxidation and the formation of harmful oxidation compounds. These compounds can be absorbed through the diet that have been linked to various health issues, including inflammatory disease, cancer, and aging. So, to combat the lipid oxidation in edible oils, the addition of antioxidant has emerged as a key strategy. This study focused on garlic essential oil (GEO), a natural antioxidant derived from plant sources, and its potential to enhance the oxidative stability of sunflower oil. By employing advanced analytical techniques such as FTIR spectroscopy, we aim to characterize the composition of GEO and evaluate its effects on sunflower oil under accelerated storage conditions. This finding will contribute to a better understanding of how natural antioxidants can be utilized to improve food quality and safety.
The objective of this study is to determine how garlic essential oil concentrations affect sunflower oil oxidative stability under accelerated storage conditions. Next, to use Fourier transform infrared (FTIR) spectroscopy to monitor sunflower oil chemical composition changes, specifically the degradation of unsaturated acyl group cis double bonds and the generation of hydroperoxides and aldehydes. Lastly, to determine whether sunflower oil's oxidative stability and shelf life are affected by the garlic essential oil's antioxidant or pro-oxidant properties.
About the methodology. The first one is the sample oxidative conditions. Steam distilled garlic essential oil (GEO) was acquired from a local company supplying ingredients for the food industry, and refined sunflower oil was acquired from a local supermarket. GEO was added to sunflower oil at 0.05%, 0.5%, and 10%. Enriched and non-enriched sunflower oil were submitted to accelerate the storage conditions. Let's move to the procedure. Several 10 grams samples of sunflower oil held in crystal petri dish of 80 mm diameter and 15 mm height were placed in a convection oven with circulating air without being stirred. Oven temperature was maintained at 70 degrees Celsius and with a stability of 0.5%. The petri dish were introduced into the oven without their lids to facilitate the exposure to the circulating air. The experiment were carried out in duplicate and samples were studied daily by FTIR until polymerization of the samples. Sunflower oil was mixed with 0.001%, 0.005%, 0.05%, 0.1%, 0.5%, and 5% of GEO and subjected to accelerated storage condition for 7 days. This period was selected because it is when the highest concentration of hydroperoxide is detected is in non-enriched sunflower oil. Next, I will move to the infrared spectra acquisition. A film of small amount of sample, approximately 2 microliter, was placed between two discs of KBR, 32 to 3 mm, avoiding the presence of air and screwing the screws of the sample holder as far as possible so that the path length was constant for all the samples as in the previous studies. All spectra were recorded from 4,000 to 500 cm (-1) with a resolution of 4 cm (-1). For each spectrum, 32 infrarograms were co-added before Fourier transformation and 0 fields to give a data point spacing of 1.9 per centimeter. The measurement accuracy in the frequency data was better than 0.01 centimeter negative 1 because of the laser helium neon internal reference of the instrument. Next, for the spectral analysis, all samples were prepared and analyzed twice by FTIR in individual experiments, which were carried out in duplicate. The statistical significance of the difference between the frequency values of some FTIR bands of the spectra enriched and non-enriched oils submitted to accelerate storage was studied with a statistical acceptance of p less than 0.05.
On this slide, we have the result of our study examining the effect of garlic essential oil or GEO on the oxidative stability of sunflower oil. The table presents three different concentrations of GEO and their impacts. Firstly, at 0.005% GEO concentration, there was no significant change in oxidative stability. It demonstrated a performance similar to non-enriched oil. Next, at 0.5% GEO concentration, we observed decreased stability with faster oxidation and earlier polymerization occurring by day 8. And lastly, at 10% GEO concentration, the oil showed increased stability with slower oxidation and polymerization recorded by day 39. This slide presents the FTIR spectroscopy observations for sunflower oil treated with different concentration of garlic essential oil. We analyzed three key FTIR bands. First, 3469 cm negative 1, which is hydroperoxides. For oil with no GEO, the hydroperoxide peaks appear on day 7 and decline after day 9. At 0.005% GEO, the pattern was similar to the non-enriched oil, while with 0.5% GEO, the peaks occur earlier by day 5, showing faster oxidation, and at 10% GEO, minimal changes were observed, indicating enhanced oxidative stability. Next, 3008 centimeter negative 1 cis double bonds without GEO, the band decreased significantly over time. With 0.005% GEO, the behavior was similar to non-enriched oil. At 0.5% GEO, the decline was slightly slower. With 10% GEO, there was barely any decrease, showing strong preservation of cis double bonds. Lastly, 1746 cm negative 1 aldehydes. For oil with no GEO, aldehydes started accumulating by day 6. With 0.005% GEO, the decline was slower, producing fewer aldehydes. At 0.5% GEO, aldehyde formation slowed further. Lastly, with 10% GEO, we observe the slowest decline, indicating the greatest inhibition of oxidation.
Now let us proceed to our discussion, and for now we have two different analysis, which is the qualitative analysis and the quantitative analysis. For the qualitative analysis, we have identification of functional group. The FTIR spectroscopy allows for identification for specific functional groups in the oil sample. For instance, the presence of band corresponding to hydroperoxide near 3469 and aldehyde near 1746 indicates the formation of oxidation products. The degradation of cis double bonds in unsaturated acyl group is monitored through changes in absorbance near 3008 wave number. Then for the comparison of spectra, by comparing the FTIR spectra of enriched and non-enriched oil, the study can qualitatively assess the impact of GEO on the oxidative processes occurring in the sunflower oil. Then for the qualitative analysis, we have the absorbance measurement. which the intensity of specific absorption bands can be correlated with the concentration of the oxidation product. For example, the increase in absorbance at the hydroperoxide band can be quantitatively analyzed to determine the extent of oxidation over time. Now let us continue on the discussion, which we have the accuracy and precision, sensitivity and detection limit, and also the selectivity. For the accuracy and precision, the FTR spectroscopy is known for its high accuracy and precision in measuring absorbance values. The ability to detect subtle changes in spectra allows for reliable monitoring of oxidation processes. And for the sensitivity and detection limit, the FTR is sensitive to changes in chemical composition, but the detection limit for specific compounds may vary. The study effectively identifies the key oxidation products, although the detection of trace levels of certain compounds may require complementary techniques. For the selectivity, the FTR is also selective for functional groups, allowing for identification for specific oxidation products. However, overlapping absorption bands can complement the interpretation of spectra, particularly in complex mixture. Then we also have the robustness of the FTR, which the method is robust under controlled condition, but variation in sample preparation or environmental factors could affect the result. Next, to continue our discussion, we have the advantages and disadvantages. For advantages, we have the rapid analysis, which the FTR provides quick result, 1 until 2 minutes per sample, making it suitable for monitoring changes over time. It also non-destructive because the technique does not require extensive sample modification, preserving the integrity of the oil for further analysis, but it also have the disadvantage or limitation, which are the overlapping bands. The presence of overlapping absorption bands can hinder the accurate quantification of specific compound. The complexity of interpretation also, the interpretation of the FTIR spectra can be complex, requiring expertise to distinguish between closely related functional groups. So to improve this disadvantage, we can use the complementary technique which is to address the limitation of the FTR. The study could incorporate complementary methods such as GCMS, gas chromatography, mass spectrometry, for more detailed analysis of volatile compounds and better quantification of specific oxidation product. We also can have the advanced data analysis, which we can employ the chemometric techniques such as multivariate analysis that could enhance the interpretation of complete spectra and improve the accuracy of quantitative assessments.
In conclusion, this study on the effect of GEO on sunflower oil oxidative stability during accelerated storage condition using FTIR spectroscopy has demonstrated the usefulness of this technique for monitoring the changes occurring in lipids under these oxidative conditions in a fast, simple way from 1 to 2 minutes and without any previous sample modification, which in return avoid the formation of artifacts. As described above, it was possible to obtain very valuable information on the oxidative process by paying attention on only to 3 bonds of the FTIR spectra. The effect of any potential oxidation, compound or mixture of compound must be studied carefully because it can differ depending on the concentration tested. In this context, it is great of importance to use specific methodologies such as FTIR, which able to track the degradation of substrate, which is the unsaturated lipids, and the formation of oxidation compound, and to conduct the study under the oxidative condition as close as possible to those of the real system, which it would be applied.